Hi, and welcome to our third and final video on this section on using differentiation. And in this one, we're going to be having a look at when functions are increasing and decreasing. So what we're going to do is identify ranges of values for when the curve has got positive gradient, i.e. it's going up, it's increasing, or it's got a negative gradient, i.e. it's going down, it's decreasing. So here we go. It says find the range of values of x where that function, x cubed plus 7x squared minus 24x plus 3, is increasing. So let's just have a little look at the diagram. Clearly what's happening is from that point onwards, our function is increasing because it's got a positive gradient. So it's going to be increasing for any value of x from here upwards. And likewise, it's going to be increasing for any value of x up to that point there as well. So we know that if the function is increasing, then the gradient is going to be positive. So what we're saying is that f dash x, our gradient function, has got to be greater than 0. So let's do the differentiating and see what happens. So here's our function, differentiate it. We're going to get 3x squared plus 14x minus 24. And therefore we're saying that that thing there has got to be greater than 0. So what we've got now is a quadratic inequality. And you should have seen earlier on in the course how to deal with a quadratic inequality. So what we're going to do is solve that. Hopefully it will factorize. Let's have a look. And yep, it will factorize. So we've got that. From here, we've got to figure out our critical values. So coming from our two brackets, we've got a critical value of here that's going to be 4 over 3. Critical value from there is going to be minus 6. So we're going to state those critical values clearly. And then we've got to put it back into the context. Say, well, fx increasing when? So here, this is going to be our 4 over 3. So it's going to be increasing for that section there. So when x is greater than 4 over 3. And decreasing for when x is less than minus 6. And there we go. So this was just a case of stating our function in terms of an inequality and then solving that inequality because we knew something about the gradient, i.e. it's increasing, i.e. it's positive, therefore it's greater than 0. On we go. It says use calculus to show that the curve y equals minus x cubed over 3 plus 3x squared minus 11x plus 4 is always decreasing. So always decreasing means that the gradient is always going to be less than 0. So there's our gradient function that's already popped up on the screen, minus x squared plus 6x minus 11. And we've got to show that that's going to be less than 0 for all values of x. A couple of ways of doing this, but I'm going to go for completed square. So if we take our gradient function and write its completed square, the issue is this minus, so we're going to have to take the minus out of the bracket outside first. So there we go. Notice minus 6x gives me the plus 6x, minus 11 I've just left at the end, I haven't touched that, so this bracket here is just the first two terms. Let's now do completed square on what we've got inside the bracket here. And hopefully we can call, there's our completed square, half the 6x, so it's got x minus 3 all squared, and take off the 9, and there's our minus 11, still just sitting on the end, not doing a whole lot at the moment. Multiply out the minus part, so we've got minus x minus 3 all squared, we've got minus 9. That's making that minus a plus, and then tidy it up at the end. So there is our gradient function, just written in completed square form. And what we've got to do now is demonstrate that that thing is always going to be less than 0, and you have to be very, very clear. It's no good just saying, oh yeah, it's definitely less than 0. The examiner's going to want to know why you're saying it's less than 0, so you've got to justify it. So let's do that justification. So we're going to demonstrate that this thing here will always be less than 0. Well, let's start off with the squared term, and we know that x minus 3 all squared is always going to be positive because it's squared. So regardless of what we have for x, that will always be 0 or greater. What that means is, there we go. What that means is because I've got a minus here, it means that that thing there, minus x minus 3 all squared, is always going to be negative. And if that bit's negative, I'm then taking away a number. So I've got a negative, take away another negative. That means our expression is always going to remain negative. So what we've done there is use a kind of a logic argument, and we've clearly demonstrated that the gradient function is always less than 0. So the curve is always decreasing, and I've chucked up a sketch of it there so you can see clearly it is always going down. The gradient is always negative.